Hello. Well, some of us, as you can see, can cope nowadays only with the aid of special equipment. But I've managed to solder up the two RM024s. I put this one in a little potting box with its own 5 volt to 3.3 volt regulator. This is a quarter wave 2.4 gigahertz monopole antenna, which is 30 millimeters long. The antenna is made by Laird and is appropriate for use in on non-licensed devices in the 2.4 gigahertz band. If I simply plug the RM02 into a USB serial converter and plug that in to the system, we can use this Laird configuration utility, which will automatically talk to the RM02, and we can read data from it and configure it in this way. At the moment it's configured with a data rate, an RF data rate of 280k bits per second, and frequency hopping using 43 hops at full power for a European licensed system, which means at 10 milliwatts. I think the way this thing works is it sends a packet from transmitter to receiver, and presumably that packet has some kind of CRC check on it, and the receiver sends back an acknowledgement if it receives it okay. If not, it retries it 3 times. There's also a forward error correcting mode that we could select here, where the transmitter adds additional information to the packet which enables the receiver to correct a certain number of errors, thereby reducing the number of retries required, but at the same time increasing the packet length and therefore reducing the throughput of the device. I'm going to use it in the default mode, which is without the forward error correction, and I'm going to use it at a baud rate of 9600 for the serial line, which is more than enough for our purposes. The unit does have a clear to send signal, which I've wired up so that the micromite can avoid sending data to the transmitter when it's already busy sending previous data out. But I'm not actually going to use that for this test. I'm actually sending out 177 bytes every second, which is more than enough to be handled by both the 9600 baud serial rate and the 280k BPS RF rate. So we'll just hope for the best and see whether any data is missed out. The other thing I have to do is to configure the destination MAC address for point-to-point operation. You can see that this unit has a particular MAC address, and the other unit, the receiver, has a MAC address, so I need to put the receiver's MAC address in there and vice versa. Otherwise it won't communicate at all. Well, here we are on Stony Cross Airfield again. Not quite in the same place as before, because I had to move 100 yards up the runway because of the horses up there. And here is the new equipment, the RM024, with its little itsy titsy 2.4 gigahertz aerial, and the same bamboo stick as before, except a different RM024 on the top. So now we're going to see what the range is of this. Well, this produced a really poor result, as you can see, something between 66 and 87 meters. When I got back to the car, I realized that the RM024 is operating in the 2.4 gigahertz band, and I've got the receiver in one hand and my laptop in the other hand, and the laptop has Wi-Fi and Bluetooth, which also operate in the 2.4 gigahertz band. So I turned those off on the laptop and reran the test. This gave a better result of 194 meters, which is quite a lot longer than the HC12. The best result there was 137 meters. When I got home, I realized that I also have a USB dongle for a wireless mouse plugged into this laptop. So I decided to do another test without that. But meanwhile, I also changed the software to monitor the clear to send signal from the RM024, so that the Micromite did not transmit when the RM024 was not ready. It turns out, in fact, that the RM024 was always ready, so that wasn't a problem anyway. And that produced this result, which is very similar to the one the day before, except it's swapped around. Notice the sort of lack of consistency from one day to the next, but the removal of the wireless dongle didn't noticeably improve the results. When I got home, I realized that I also have a mobile phone in my pocket, and that's got Wi-Fi and Bluetooth enabled. So I decided to do another test the following day with those things turned off. And I also changed the configuration of the RM024 to increase the retransmission count from 3 to 10, so that if the packet doesn't get through, it retries it 10 times rather than 3 times. There's plenty of time for it to do that in the 1 second between Micromite transmissions. I didn't expect it to make a big difference, but I thought I'd try it. This didn't really make much difference to the range when I was walking away from the transmitter, but on the backward trip walking towards the transmitter, I deliberately held my bamboo cane, which holds the receiver, as high as I could in the air, showing, and that produced a better result of 238 meters, showing that having the receiver high in the air does improve the range. Well, I'm here on Stony Cross Airfield again, and I've just finished the test that I've predicted I was going to do. And there's one further test that I want to do, which is to raise the transmitting aerial into the air further to see whether that is the fact that the aerial is too close to the ground may be the primary reason for the lack of range. So what I've done here is put it on my photographic tripod, where it is just above the top of my hat, so about 6.5 feet, and the electronics is still on the ground there. So I'm going to run a test like this, and we'll compare the results when I get home. Well, this final test with the transmitter at a height of 195 centimeters and me holding the bamboo pole with the receiver also as high as I could with my arm, gave a reliable range of 438 meters. Of course, however, that is not practical from the point of view of being used with Snoopy. Well, what conclusions have I reached? Firstly, the RM024 does give a significantly longer range than the HC12. Secondly, it's very important to remove all extraneous 2.4 gigahertz equipment from the location of the receiver. And that's quite easy for us to do, really, so long as we just remember what we're doing. Thirdly, I think one can't really tell how this is going to work when the transmitter is fixed to the top of Snoopy's mast, because the mast will be waving around as Snoopy sails, and
the antenna isn't exactly omnidirectional, so we actually need to test this in real life to see what the real range is. And at the moment I'm somewhat disappointed that the range is not, that I'm getting under pretty ideal conditions, is not as much as I would like for our purposes. That's all.